One thing now that I, have such a fascinating conversation partner, I was always curious about is how should I think about data sizes in the brain, right? So I read a lot of things around, the brain can process so and so much data, but then, there are other concepts where the brain is phenomenal in kind of data reduction, right? So, asking the expert how to think about data computation and storage capacity of the brain, and is there ways to estimate that?
So I don't think that's a fully understood process. Like how the brain memorize or store memories is a process that I don't think is completely understood yet. But overall, people kind of have a general consensus on like what we agree upon, what we call the Hebb hypothesis. So Donna Hebb is this neuroscientist. Basically said like, okay, the pattern of neural activity is essentially a trace of memory, essentially, right? So we know that neurons are highly connected, right? Every neuron connects to thousands of other neurons, right? And essentially you could think of it as, like you have one neuron, and then let's simplify, let's say each neuron connects to 3 other neurons, right? And then something like that, and then you have some others. So if you have neurons like kind of all over the place like this, right? So some of these neurons may actually have feedbacks, right? May actually connect to this one, and this one actually feedbacks to that, right? So the way the brain actually works is that when you activate one neuron, right? If the connection is strong enough, right? What that means, what it means to have a strong connection is that when this one fires, right? Say like this one actually fires. Right, this one also fires. Right. So then that means this 2 neurons have a strong connection. Right. So the way you form this connection is that neurons that fire together tend to become more well connected, more strongly connected. Right. So now when these neurons, if you think of this as if it's a fully connected network, right? Some of these connections are strong, some of them are weak, right? But some of them. When say you activated like this neuron, right? You activated this neuron. Say you activate it, and then it's gonna fire, and it's gonna fire. It's gonna fall through some strong. Some of them have multiple strong connections, so they may actually go to several places, right? And then some of this we eventually maybe through this neuron it comes back, right? So this loop persists, right? Because if this one is keep activating, then this loop is gonna persist. So that kind of pattern of activation is what stores memory. Right? It's a very strange and way of storing memory that's very, very different from our computer hardware.
But so this just, it's so funny. It just reminded me on kind of the graphs I painted when we implemented PageRank in Nudge early on, right? So kind of like, how obviously it's a graph, but how do you weight each of the connections, and what comes first, and what's the time sequence behind this?